Lights, camera, action. Well, we know that's the main ingredients on a movie set. And they know how to do it. And we can learn from them. When they get the period correct, the correct buildings, vehicles, the backgrounds are correct, all the participants are there. But the main ingredient of it all is the action behind it. And we're looking at animation today. What's the definition? Well, it's all about life. How often have you been to a model railway exhibition and you've wondered at the beauty of the layouts, the periods being accurately represented, the buildings are beautifully constructed, the locomotives crafted beautifully. But nothing moves but the trains. If you're prepared to spend the time to accurately reflect the railroad, why not spend that same time to accurately represent the milieu in which the railroad sits? And that's what we're looking at today. A number of different methods to get some life and animation into the layout. We'll start off with some of the very simplest and work our way up. We'll be looking at methods that our members have devised to get animations on layouts, including the list you see here. Let's start with a very simple DC motor that can be directly wired. You simply put the power to the motor turns, and it does what it does. Or we can have the motor giving us motion that limit switches that stop it at certain positions. And that's covered in some detail on an existing YouTube video that you'll find on the WOZAG YouTube channel. Or we can use various electronic modules such as timers and microcontrollers to make it do things in a particular fashion. Let's start with the very simple. If you directly power up a motor, it can work conveyor belts, water mills, windmills, Ferris wheels, any number of different devices with hardly any wiring, just the power to the motor. And yet it brings activity and life to the layout. That's a scene from one of our demonstration layouts. At the back, you'll see a cement mixer. You can maybe just see here a rod that hides in the cab, hides behind the man in the waste bin to rotate that way. So the motor is actually under the baseboard itself. Simple but effective. And on our showcase, we've got a helicopter as an example of a direct drive DC motor. John McMorran has designed, 3D printed and constructed and controlled a coal mine shaft with two DC motors, one for the winch and one down below to move the coal carts. It uses limit switches, so we know when we've got to the top or the bottom of the shaft itself. At the end of the movement, it touched the limit switches and cut off the power to the motor. And of course, John has also added in sound effects for even greater realism. Another way to use a DC motor is its ability to create a piston or a cam effect. And again, on that same demonstration layout, we've got a schoolyard. And it features a swing, a merry-go-round, and a seesaw that are all animated. Let's see it in action. Once again with sound effects. So, how did we achieve that? Let's look underneath. You can see that we have three motors. One that operates the roundabout, one that acts as a piston that moves a length of piano wire back and forth. On the end of the piano wire is a magnet, and it pulls the metal of the swing back and forth. And the third motor has a cam that operates the seesaw. Fred's model of a fairground attraction also uses the idea of a motorised piston, as you'll see in a moment when he reveals the motor on the left hand side. Very simple, but an effective method nevertheless. A DC motor can also provide long and controlled linear movement. This advert shows a lead screw, which is essentially a threaded rod with a nut on it. And as the rod rotates, the nut runs up and down the rod. It can be used with a DC motor with limit switches at each end, or, as in this example, a stepper motor operating it, and the stepper motor itself being controlled by an Arduino Nano and stepper driver. That way it can have defined stops along the way, like this. The speed of movement depends on how fast you run the motor. Simple as that. And the maximum travelled distance depends on how long a lead screw you buy. They come in different lengths. And here is an example of it making an intermediate stop. This method is commonly used when building traverses, for example, but we can use it for animation purposes, as shown in the next couple of examples. One of our demonstration layouts features this road roller. It runs in front of a hedge, but if you look behind the hedge, we will see that a rod from the roller goes down a slot and then connects to the moving nut of the lead screw to provide the linear movement, as in this video. The movement is slow, smooth and prototypical, and there are limit switches at each end of the travel, and so it detects the arrival at the end, switches off the motor and then reverses the direction of the motor. And here we have an even larger implementation. You can just see at the rear of the layout an elevated canal with a moving barge. Something you don't see too often on a model railway. And it is using an even longer length of threaded rod. Top right, you can see the DC motor that drives it, and you'll also see a micro switch at each end of the travel and one in the middle. So it can trigger activities at 3 different places. And also top right is a PIC chip and a 293D driver that controls all barge movement and other activities. Let's have a quick look. A nice, slow, even movement. You may have spotted some welding going on in the factory there using the multi-purpose flasher kit, and a tram just passed by. It's an extra animation on the layout using the Merg Simple shuttle kit. You sometimes find layouts that incorporate moving vehicles and bicycles and lorries and so on. And they do help, but they're expensive. Probably the most common system is the Faller system. And even the starter kit, which is pretty limited, is costly. And all the add-ons make it even more expensive. It uses the wire following method, where each vehicle has its own power pack and they follow a metal wire which has to be embedded in the road itself. Another wire follower is the Viessmann car motion system, which is even more expensive. Other manufacturers of course are available, including MCC, Dynamo and Cree Model, but they're all pretty expensive to implement. A non-wire following method that is used by one competitor is called MagnoRail. As before, even the starter kit is expensive, and it's a motorised chain system that has to run in a channel that you embed in the layout. One alternative, if you've got a 3D printer, is to download these plans to construct a similar type of road system that uses a motorised chain system. Notice, however, you're constrained as the road channels are interlinked sections of preset shapes which offer limited options. It's almost like the Skeletrix racing car system, except that it has magnets attached to the chain to pull the vehicles round the circuit. So, with these road systems being expensive and restricted, is there some way that we could do our own system of belt drive, chain drive type of setup? Something that's cheap, something that's more flexible and perhaps quieter. Let's have a look. While surfing the net, I came across this. It's a plastic gear and chain set designed for use with Lego, and it seemed ideal for our animations. At that price I had to try it. It arrived in 2 bags like this, one containing the chain links and one containing the gears. The links all clip onto each other to make a band of any length you require, and they can adopt any shape around the series of various gear wheels. Here you can see a simple example of the kit in use. With a single band, I didn't use the motor that you can buy from Lego. Instead I used one that I already owned. You can see that I've glued a neodymium magnet onto one of the links to allow for various effects to be initiated when it passes a reed switch or Hall effect switch. I've also glued just a single person onto one link just to show what's possible. It could be a whole row of people crossing its traffic lights, traversing a walkway or whatever. Or if you mounted the whole thing on its side, it could be used as a factory conveyor belt with various objects glued to the links. If you want a more precise system, you could consider using the belt drives that are available for moving the heads in 3D printers and laser engravers and such. They're relatively cheap and can produce good results. Here is one set up just to show as an example. You can see just how slow you can make the movement, which would be handy in certain situations and certainly for smaller scales. I had occasion to change both my blinds and curtains in part of my house, and I thought, what the heck, all kinds of things can be used to create movement. So here is the blind mechanism to which I've attached a motor. I've now got my very own chain system working quite happily, and now at a slower speed. I then turned to the 8-foot string pull mechanism for the curtains, and I thought, all I need to do is put the string through a couple of rollers, remove one of the pull tabs, motorise it, and I've got a long linear mechanism like this. I can control the speed at which it operates through the motor speed. I can have it slow if I wish, or I can rev up the motor and have it operate at a faster rate depending on what my needs are. I even recovered the mechanism from one of these old sprocket fed paper printers with the idea of putting a motor on that. So if you only want a small amount of movement, there's another option for you. With a little bit of thought then, we can use all sorts of things to give us animation. But a very commonly used method is with servos. We use them for operating points, semaphore arms, uncoupling mechanisms, etc. But they've a lot to offer in the field of animations. There are lots of ways that they can be used, but we'll start with simple rotation. Making the servo arm move through an arc movement allows us to do all kinds of basic animations. Consider this barrier gate. The servo is in plain view, albeit painted black, sitting on top of the layout and operating the barrier arm directly. A train detector module spots the approaching train, triggers the Easy Points module, which lowers the barrier until the train passes. There's no special programming involved, just connect the train detector module to the servo module and it's good to go. And here a simple 90-degree arc of the servo arm will happily operate crossing gates. Manually in this case, using an Easy Points kit and a push button, but could equally well be triggered by a track occupancy detector. On one of our demo layouts, there's a crane also with a 90-degree rotation. The servo is mounted under the baseboard and directly connects to the crane and is triggered by a sequence of events that we'll be looking at later. On the left of the layout is a water crane that comes round when a loco enters that particular siding. Again, a simple operation. There's a reed switch under the track and the load in the wagon is in fact a magnet. When the loco comes into the siding, the magnet operates the reed switch and the switch triggers the Easy Points kit to swing round the crane, as we can see here. On the other demo layout we have a small station, and when the train arrives it's detected, this time by a light dependent resistor embedded between the sleepers, and when that happens it brings on a light in the station and out comes the station master, as you can see here. In this example, Douglas has yard gates on his layout, but this time it's operated by a switch on his control panel. And he's chosen to use two servos, one for each gate, rather than try to have one operating a set of levers. In Gordon's old gauge layout, he has the servos mounted inside a van, again triggered by an LDR to make the doors open and close. Of course, a servo doesn't have to only rotate, it can be converted into a crank or piston motion. Look at the price of that railway rabbit. We could easily replicate that with a servo acting as a piston. Let's look at a couple of examples. Just behind the school there you might spot a kennel with a dog in it, and every so often as a train goes past the dog comes out and barks at the loco. Adding sound helps too, of course. And here we have a servo pushing a piece of piano wire that tips the truck's load. And Keith built it on his bench as a drop-in. You can see the servo, but it also has fibre optics to take the lights up to the truck. And the same technique was used to raise the fire engine ladder in this little scene that also combines lighting effects and sound effects. For this little scenario, John designed and 3D printed this scissors lift, activated by a servo. It's controlled by a PIC chip to provide a sequence of events. The lights on that building are faulty, they eventually flicker and go out, in which case the repairman goes up in the lift to repair it. There you are, it's flickering, lights are flickering, and eventually the light will go out, and when that happens, up comes the maintenance man in the lift to fix the problem. He works on the wiring, and eventually the light is back on, in which case the scissors lift returns him safely to the ground. This building site scene has a number of features. Top left, you'll see a man with a stop go sign. Of course, the cement mixer is always turning. We have a servo tipping another lorry load, and then one servo moves the bulldozer forward. And another servo lifts the blade. So 2 servos to operate the bulldozer. Now you can buy special mounts that are designed to house 2 servos to both rotate and elevate, mostly used for remote cameras. But Neil made up his own, as you can see on the right hand side. A local railway club were building a World War II themed layout and wanted a functioning gun, so he built this. Once again, the animation has been enhanced with both the use of lighting effects and audio. We saw earlier the use of lead screws to give us long linear movement, but what if you only need a shorter linear movement? These would be overkill, and we could instead go for linear actuators. Commercial units are available, however they tend to be pretty expensive, and consume large amounts of current to operate. Aeneas has a piece on our website about how he made his own from a DC motor. Now you can buy tiny 3-gram linear servos which are designed for model aircraft use, and they provide small amounts of linear movement. Then Fraser designed a more powerful version by 3D printing a servo mount that drives a rack and pinion mechanism. So what can we use that for? Well, let's take a look at another example from our demo layout. Robert built this drop-in timber yard that has several animations. There's a crane on the lorry, there's a man chopping wood, and you're going to see the log on the saw being moved back and forward by that linear servo. There's the crane moving, there's the man chopping wood. We saw the canal barge earlier, but this clip shows the barge arriving and triggering a micro switch which brings on the light above the door, and the linear servo brings out the van to meet the barge. And when the barge pulls away again, the light goes off and the linear servo pulls the van back into the building. This image shows a linear servo being used to operate a sliding door, and we use that in this scene on our layout. When the loco arrives, it's detected by our laser detector kit. The light comes on in the building and the man comes out. The sliding door opens, the crane comes round, and then the truck comes round from the rear of the building. Up to now, we've moved objects by direct linking or pushing and pulling using piano wire. But another option is to connect thread or better still fishing line to the servo horn or an extended horn, depending on the amount of movement required. Here is an example. The project wasn't finished at this stage, but you can see that the barge enters the warehouse, and when it's fully in, it pushes into a micro switch which then triggers a process. First, the light in the gantry platform comes on, a servo moves out the foreman, and the fishing line lowers the load onto the barge. You may also have noticed that the Merg random lights kit has been bringing lights off and on in the building. The same long arm servo technique was employed by Keith when he animated this warehouse hoist and also this excavator. Before leaving servos, I just want to include Tony's excellent wagon turntable, which uses one servo to rotate the wagon and another servo that moves the wagon into and out of the building. And also to the multiple servo car crusher that John designed and 3D printed. Fuller details are available on our WASAG website. Okay, let's move on now to the use of relays. I mean the kind that you see here with a removable cover, not the sealed type. That allows you to extend the relay's hinged armature to get greater movement. And why pay £38 when this will do the job? Or you may want a man to pop his head out the signal box window and similar small animations. I wrote an article for the Merck Journal some time ago that I called Pneumatic Man. The driller stands on a building site and the relay used is controlled by a pick chip. The pick chip vibrates the relay in a pattern of ups and downs to simulate someone drilling. One last point on animations concerns lighting effects, because animated lighting also adds to a layout's atmosphere. I'm thinking of the traffic lights kit, the welder kit, the random lights kit that we saw earlier, the OLED screen that's on the cinema, and of course the atmospheric scene created by George. Finally, I want to talk about how do we switch and control animations, because there's a number of different methods. The simplest one being that it's continually on. We already saw the cement mixer in operation. You wire your 12 volt to the motor and the watermill rotates, the windmill rotates, etc. You've nothing else to do except to sit there and watch them. And then there are ones that are user triggered. The layout operator may have a switch on the control panel that switches between day and night activities. And we saw Douglas open and close yard gates from a control panel switch. Other times you'll use a push button. When the grandkids visit, you can let them initiate certain animations. Or you may provide a push button on an exhibition layout to encourage visitor participation. In fact, the fire and the fire engine sequence you saw earlier is set off by the press of a key fob. And then there are automatic triggering. I'm thinking things like you see in the right hand example, where some kind of train detector activates a servo to do a particular operation. Bringing out the station master, switching on yard lights, whatever. Moving the water crane, all kinds of things that we looked at earlier. Nothing the user has to do. They've been set up to operate autonomously. And then there are timed activities. We can use Pocket Money Project number 20, available from our national website, the Kit Locker, where we can make certain things happen at certain points. You want an effect to happen for 10 seconds every 5 minutes, or for 2 minutes every 10 minutes, whatever it is you want to do, you can set with adjusting those two little pots that you see there. And then there are ones that are fully sequenced. We can use Pocket Money Kit number 26, a sequencer, where we can, one trigger coming in can set off a series of events, simply making a delay between the operation of two crossing gates, or multiple activities, like you saw with the shed, the door, the lights, the van, the crane, etc. All being triggered by one trigger. And then there are the more complicated ones where we actually have to program chips to do it, like the pneumatic man with a driller, like the canal barge operations, and so on. And for those we have to have some skills in programming PIC chips, or Arduinos, or the new Raspberry Pi Picos. So we've looked at loads of examples and lots of different methods to achieve animated effects on your layout. It's up to you now. You can start at something very simple or work your way up to programmed effects, depending on your needs.